those are my predictions, and so the residuals here is the actual minus the predicted. I get negative 0.6, 1.8, negative 1.8, and 0.6, and my residual squared is going to be 0.36, 0.36, and what is 1.8 squared? 3.24. And so my sum of squares residuals here is going to equal to this column summed up. I'm going to get a sum of squares residual of 7.2. Okay, so according to our criteria for what the best fitting line is, this line is a better fit than that line. Okay, y equals 1 plus 1.6x is a better fitting line than y equals 2x, because the sum of squares residual here is smaller than the sum of squares residual there. Is that okay? Alright, so we get an idea of how we go about, how to evaluate whether a line is a good fit or not, but we haven't talked about figuring out what line is the best fitting line, okay? Well, other people figured that out for you guys, okay? So you don't have to worry about figuring it out, it's just, they said, well, if you're using this criteria, that the line that produces the smallest sum of squares residual, then it turns out that the best fitting line will always have this property, okay? The best fitting line, the slope of the best fitting line will always be r times the standard deviation of y divided by the standard deviation of x. And this is known, the symbol for slope is b1. And the intercept, which we use the symbol b0, is always going to have the property y bar minus b1 times x bar. Okay. So the line of best fit is always going to have this slope and this intercept, okay? So actually when I chose this line 1 plus 1.6x, I knew that this was going to produce the best fitting line. Okay. So if we remember what, when we had our data, the standard deviation, x bar was 2.5, and the standard deviation of x was 1.291, and y bar had a standard deviation of, I'm sorry, y bar was 5, and 1.291, it had a standard deviation of 2.582. And the correlation between the two values was 0.8. Okay, so that was, these are the summary statistics when we had this other data points for x and y. So just plugging that in to calculate the slope b1 is equal to 0.8 times 2.582 over 1.291, we get a slope of 1.6. And the intercept B0 is going to be 5 minus, we plug in our value for slope of 1.6 times x bar of 2.5, and we get B0 is equal to 1. So putting these together, if we say the predicted line is in the form y is equal to B0 plus B1x, we get y is equal to 1 plus 1.6x. This is going to be the equation of the best fitting line. So our slope is 1.6 and our intercept is 1. So let me just provide interpretations of our slope and intercept. Okay. So the interpretation of the slope. The interpretation of the slope. What does it mean that the slope is 1.6? What that means is that every time we increase by x by 1, we predict that our y will increase by 1.6. So the interpretation of the slope is that if we increase x by 1, we predict y increases by b1, the slope. So in this problem, we say if a dwelling has an additional bedroom, we predict the number of closets is or goes up by 1.6. Okay, so our prediction increases by 1.6. Of course, the actual number of closets is only going to go up a whole number, but the prediction, it's fine to say our prediction goes up by 1.6. Let's talk about the intercept. The intercept is our prediction for y when x is 0. So in the context of our problem, we would say if a place has 0 bedrooms, we predict it has 1 closet. Now, it doesn't always make sense to have x equal to 0. If we're talking about the length of a snake, it does not make sense to say the length of the snake is 0. What do we predict how much the snake weighs? That doesn't make sense. But in some cases, like in this case, can a place have 0 bedrooms? Yeah, you could have a studio apartment or things like that, which I think counts as 0 bedrooms. We would predict that it has 1 closet. And that kind of works out in our example here. Okay, so as far as the final exam goes, I will ask you to calculate correlation by hand for a small set of numbers. I'll ask you to find the best fit line. I'll ask you to find the residual of a point. So that would involve, how do you calculate the residual of a point?
You find the value of y at that location x.
You find the value of y at that location, which will be given as part of your data for that point. But then you also have to find the prediction for that particular x value. And so you just plug in the value of x to get your prediction, and then you find the difference between y and your prediction. And then I will ask you for the interpretation of either the slope or the intercept.
Can you say that one more time?
I'll ask you for the interpretation of either the slope or the intercept. Let me pass out these instructor evaluations, and then after we do this, I'll continue reviewing some stuff from